So recap so that you guys hopefully don't get bored. I'm gonna do this a little bit faster because I forgot to hit record and I forgot who it was I just let in. All right, domain and range. I'm gonna treat it like you haven't seen it before, right? A relation or this domain and range are used for relations and functions. Relations and functions. Right now, we're just gonna call them a set of math rules. Math rules being, I'm going to double it and then subtract 5. Or I'm gonna take a number and triple it and then square it and then add 2 and then take the square root, like a whole bunch of series of math steps. Domain are the numbers that you can put into those things and you can do the math too. All right. Range are the results you can get from doing the math. That makes sense? A little bit. So like, if I say the rule is take the absolute value of the number and add 2 to it. Is there any number that I cannot take the absolute value of and then add 2 to? I asked that as like a negative definition. If I give you any number at all, could you find the absolute value of that number and then add 2 to it? Like if I said -4, you get the absolute value, then you can add 2, right? There's nothing that would get you stumped. If you had a calculator and you keep track of all the decimals, there's nothing that would stump you, correct? You could do all of that, no problem. So its domain would be any number, technically any real number, but any number, right? The range are the types of results you get. So if I, again, same exact idea, if I had the absolute value of a number, think about what you'd have for answers, or what you would not have for answers, and then add 2 to it. What type of numbers would you get as results? You might be jumping too fast. Let's say I just had the absolute value of a number. What can I not have as an answer?
0.
Well, I can get 0. If I put 0 in, I'll get 0 out. What could I not get out of an absolute value symbol? Negative. So I'd have to have like I'd have to have zeros and all the positives. That makes sense? That would be the range then. I would have kicked all of the negative numbers out of the range. And a lot of times, instead of thinking, what can I do? Usually you'll end up thinking of, oh, what could I not have? Because usually the list of things you can't do is shorter than the things you can do, right? There's a whole lot of numbers. I'm not going backwards for that one. They're gonna have to. All right. So domain, just remember, domain are the numbers you can put in. And I always think of this, alliterations are helpful. I think domain is what you can do, what numbers you can do. Range are the results you would get. Make sense? Oh, come on. There's my sound effect working. I hope I remember to get all of the draw things right. The pen I was looking for. Yes, these are the ones I like. All right, so these are 2 different sets. And this is a graphical, this is a way of showing the domain or range. Right? So the domain is the numbers I can do. I can only do these things. This is my little world vision. And they go that way, become this. Same thing here. You guys are going to do that one. So here, my domain, I'm just going to write it out here like this. This is not the proper way of writing domain. We're going to do it better soon. This is like the Algebra 1 way of writing domain. All right, what do I have? What numbers could I put in? Well, 2 does something, right? It went somewhere. 4 went somewhere. 6.
They all went somewhere.
8. Give me a comma. There we go. 10 and 12. And then range, the results I got And we usually use DNR because they work. We're not gonna stand for anything else. I could get 5, make that a good 5. 9, 13, 17. I'm only doing them in order because I have a little bit of OCD. And you don't absolutely have to put them in order. It's not wrong if you did 25 and then 21. Does that make sense? Look at the domain range for the other one. It's slightly trickier, but you can write ahead of me. Literally is the numbers that you could do something with. Here's the big trick, just to let you know. Is 15 part of the domain?
No.
No, because it doesn't do, I can't do anything with that. So,
The 21 would be part of the range, or no, because it didn't do anything?
can I get there? No,
No.
it's not a result I can have. So it's not there.
So then what was the?
We're gonna talk about that because it actually ends up becoming a part of the thing. Sometimes mathematicians have to deal with people making a mistake when they exclude, because usually domain and range are listed by exclusions. Then sometimes they will mess up an exclusion and you end up having to deal with that issue. It technically becomes a thing that then, technically becomes a thing that you end up having to point out the definitions of things in order to like ruin their lives. So like for instance, if we had the absolute value of a number, right? And you said the domain was just the positives, I would have to make a big deal about the fact that you didn't put 0 in there. Then we couldn't get to 0. Does that make sense? Because 0 is not positive, but you can take the absolute value of it. That's not the best example. The best example would be if you had something that only had the positives and you put 0 in there on accident. You then made it not a function because you have a number that can't be used. Limiting your domain too much is actually often less of an issue, or range, same thing for range, is often less of an issue than not limiting it enough. I don't know that that's always true. Seems to be true for what we're doing. All right, what'd you get for the domain here? Pretend this is a brace. 1, 5, 6, 7, and 9 and 13. This is not difficult at all yet. Embrace that. We'll have the time soon, you know. I don't know how that blue's gonna show up. All right, then y'all got 5, 9, 13, 17, and 25. Everybody's good? Yeah, you can do domain range just a little bit. All right, now I'm giving this to you so like note-wise you can see it all. Now we're looking at ways to write domain and range. I'm never going to tell you which way of these two you have to write it. You have to be able to read both. And in pre-calculus, they eventually become more particular and they'll say, oh, this time write it with set builder. This time write it with interval notation. At times, usually one is easier than the other. Depending on the function. Usually, if interval notation becomes a big ugly mess to write out and it's really complex to write out, then set builder is going to be fairly simple. Or if set builder becomes really hard and complex to write out, interval notation becomes kind of simple. These are the two ways, and my poster's up there that you people virtually can't see, which is one reason why I did it this way. Really, really important for how to write these, and you can scroll through this at your own pace if you need to read it. Interval notation works great if your function is all contained in one piece. That's when interval notation is awesome. If your function has like jumps in it or breaks anywhere along the function, if it's not continuous. If it's continuous, and continuous just means that it starts somewhere or negative infinity and just keeps on going without any jumps or breaks. It's a continuous line or curve or anything. It can go many directions, but it never like, you can go through the whole thing, but looking at your pencil, it's a graphical way of looking at it. But it never has any jumping off points or breaks along the line. Then interval notation is going to be awesome and short. Because interval notation goes domain that goes left to right of the leftmost piece continuing up until the rightmost piece. Well, if it's all in one piece, that's easy. Same thing for range. It'll go from the bottommost piece up to the topmost piece. I feel like I'm not talking right. I wrote it down in 6 steps, but I was really being like as precise as I possibly could along the way. You start off by saying either D or R, right? You do left, your interval goes from left to right or bottom to top. Left, it goes from lowest to highest, right? So if it's domain goes left to right, it's the X values. So it'll be left to right. Range is the Y values, it will go from bottom to top. Right? What messes up some students is the top might be over here. So they'll think, oh, the graph goes from infinity all the way down to negative infinity. No, range is always bottom to top, regardless of the order it goes in. Same thing, domain is always left to right, regardless of the order it goes in. When you see like this whole stuff here, where, like if there's multiple sections, you put a big ugly U. You put, it's technically a union symbol in between them. We're not going to have to deal with that a lot because my personal rule of thumb is if I see multiple sections, I go to set builder because set builder will be easier. And we're not going to have for a while very many functions that have multiple pieces to them like that. Anybody like me to see? You guys have that. I'm gonna write on the chalkboard the most, well, yeah, we'll go back and forth. I'm gonna write the most common domain or range you're gonna have. And then try to explain this a little bit. Okay? Yay. Oh, I put that. I'll get the red going. So usually, typically, you know, like put any number in, you get any number out, right? By the way, that's the most common thing. Most common. Y'all have seen this before. All real numbers. Y'all with me or no?
Someone just.
Y'all did some domain range in Algebra 1.
Yeah.
If it was a line, you had to do domain range, the domain was going to be all real numbers because it went everywhere, right? It went as far to the left as possible, it went as far to the right. It went as far down as you could go, it went as far up as you can go. And typically, God bless you, God bless you twice. How do you know about typically? Quite often, like there's nothing major issues going on. your domain is gonna be all real numbers and your range is gonna be all real numbers. You'll typically know and see something happening that's different if it's not. Now, be prepared for a lot of things to not be that for like the next week and a half, maybe 2 weeks, because I'm trying to like get you used to like writing domain and range and thinking about it. So I'm gonna show you things where weird stuff happens. But like when we're just typically doing math and just going through a chapter or whatever, be prepared for all real numbers. When in doubt, all real numbers is gonna usually work. So if it's interval notation, all right, all I would do, and this is just to like show examples, because I'm gonna have different types. All right. Interval notation, I'll write a D to let someone know two things. One, that I'm talking about domain, and two, that I'm not plotting. Because interval notation can look like a point sometimes. You need to let them know that we're not talking about a point. We talked about this a little bit when we were doing like solving inequalities. My leftmost thing is negative infinity, correct? If it's all real numbers, numbers go that way forever, right? I can't actually get to negative infinity. I can just approach negative infinity. So it gets a parenthesis. Y'all remember me talking about putting my nose in the corner? Okay, good. Couldn't remember what, making sure I'm telling that to every story, you know, every class. Embarrass myself as much as possible. All real numbers keep on going forever that way, all the way up to infinity. I can't actually touch infinity, so it gets a parenthesis. Range is exactly the same thing. If it's all real numbers, I put an R for range, but y'all see how that could be a point. Like if I only went from 3 to 6, it could look like 3, 6, like a point on the graph. When really I'm saying from X is 3 all the way to X is 6. So just to be safe, we always label it what it is. All real numbers still the same thing. That's an ugly infinity symbol, all right? But I'm gonna write how to do all real numbers up there for both versions. So you can at least do the default. If you're ever taking a test and you're not sure, you can't remember how to write the answer, you know it's not this, that at least will look like you know how to write domain and range. That's not necessarily the recommendation, but it's better than IDK. All right, and you don't have to write an interval notation. I'm gonna show you interval notation set builder. Typically, I'll tell you to pick one, get comfortable with one, and then you'll start working on the other one. You have to be able to interpret and read them both, but that's about it. So here's some different examples. I gave you some fun functions and some like not so important functions. This one's linear, that's all real numbers, right? It goes from negative infinity up to infinity. Sorry, it goes from left, negative infinity, all the way across to positive infinity. And it goes from down, way down here at negative infinity, all the way up forever to positive infinity. That's that function. Notice the two on the left are continuous, the two on the right, not so much. Oh, that did not copy in right. That domain is not right at all. All right, watch what I'm gonna like write over this one. It'd be great if we could fix that. Oh, I can do it here maybe. Really? Hold on, I'm gonna make it part of the notes first. Zero. Doesn't actually touch Thank you. Doesn't actually touch. So it's supposed to be negative infinity to 0, both in parentheses, big U, and then 0 to infinity. So here, and the range is there. We'll look at this one next. The sine wave, we're not going to have sine waves in this class. You may see them from time to time, but I'm never going to make you do anything with them. I always have hopefulness. If we like complete everything we're supposed to complete in Algebra 2, and that would mean that y'all are like an awesome class in every single way imaginable, then I'll say, great, let me prepare you for half of pre-calculus and just give you like a little smidgen of the trigonometric functions. Mainly because I love them and I think they're great and awesome. And if you see them presented well, they're really, really easy. But the cool thing about a sine wave, it never gets lower or higher than -1. It'll go on forever in both directions. So its domain is all real numbers, but its range, it will hit -1 at its lowest point. Notice that's not the leftmost point. That's the lowest it goes. And the highest it ever goes is +1. But it hits both of them, so it gets corners, because you can touch corners. All right, up here, other than me messing up, oh, I can probably write right over it. Right. I don't know how that messed up like that. All right. The domain, negative infinity to 0. It doesn't actually hit 0. So if I'm looking left to right, I have a graph, I have a graph, I have a graph, I have a graph, and you see something wonky is happening here. All right, because the graph is going way down, and then almost immediately, as soon as it gets past this little axis of weight, it's coming from way up high. You know something crazy was happening because it's going down as low as possible, but it's coming out of the ceiling, which makes no sense, right? We'll talk about it. It'll actually make sense at some point. But so I go, and I never actually hit 0. You'll see that live eventually, right? And then I have a jump. Every time there's a jump, it gets a union that says, so I have this piece doing this. And then there's another piece right over here, which goes like this, and it goes just from 0 all the way out. Range is the same thing from bottom to top. I have a graph. I'm way down negative, and I go up and up. And as I get close to this line, I make a jump right there at 0. This one, by the way, since there's like that jumpy stuff, that would be really easy to do with Set Builder. I got whole boxes like of weird things going on. It did not look like that before. I was sure of it. Here, leftmost point, I can't, that's an open circle, so I'm not actually touching that. So it goes from -2 all the way over to 2, that's the x value, and I can touch that one. So it gets corners. Well, is that true? No, I could have done that the other way, that would have been better if I'd done that way. Range, lowest point is -1, that's open. Highest point is +1, and that I can't touch. Okay-ish. I'm gonna move on. The other way of writing things is Set Builder. Now, you guys in the class have an advantage if you can see my really, really old posters over there that have the 4 big groups of numbers. Natural numbers, rational numbers, integers, and real numbers. The big one is real numbers. We'll at times use some of the other ones. I'm hoping that your Algebra 1 classes talked about those groups of numbers. Anybody completely unfamiliar with natural, rational, integers, and real numbers? You can either write it in the chat and I won't out you, or you can say something in class and I won't out you. But if so, I'm gonna go over like a minute and a half explanation of them. 5 seconds, 4, 3, 2. We're okay with that? All right. Set builder's really cool thing is I can use symbols like these to make shortcuts. Usually it'll be like not equal to or less than, greater than, all that stuff. Or I can use words. So, because once I get inside my little set builder piece, I then have the freedom to describe my groups of numbers or describe my set almost any way I can. So like I can list them out. I can say X, I can literally write X has to be an even number. That's what it has to be. If I can't think of a symbol or a way of like symbolizing even numbers, there's a way to do it. I'm gonna go to the chalkboard real quick. I click. Don't you do the whole freezing thing. Okay. Third block, my cameras will freeze. All right. So if I'm doing all real numbers for domain, it's really simple. I don't have to have any labels because once I start using set builder, it becomes really apparent what I'm doing. I don't even have to label domain and range, like as it being domain versus range, because I start with a brace, and the very first thing I do is I tell you what variable I'm using, which is nice because it's not, if I'm not graphing, it's not always going to be X and Y, right? So no matter what, I can already say, ooh, this is the variable I'm using, and this is, I'm going to show you how to read it. So it's X. That line right there means such that, or as long as, or given that. You guys had geometry. Y'all remember the whole givens and your teachers avoided fruits?
No, I just love fruits. I didn't pay attention.
But you at least remember the word given. Okay. See, don't lie to me. This would be like X given that. So like this is just saying I'll have X and I can use X as long as these conditions are met. And once I get here, I can just start writing. I could write, if I forgot how to do it, that is legal. That's perfectly fine. I can, and you'll actually see like some textbooks show it this way. This is my domain, X as long as, or given, or such that, or any like, whatever language you like that says, as long as this thing happens, right? So this would be X given that X is real, which makes total sense, right? That will work just fine. Typically the way you end up getting there, the most mathematically professional way, or the most like proper highest level way that you'll end up seeing it, would be the brace X line, right? And I'll write X, and this is technically an epsilon. Is epsilon on the little thing? It's technically a lowercase epsilon, but it's not the little bumpy one. It's a C with a line through it. That E right there. That is the mathematical symbol for is an element of, or belongs to this group. So this is X, as long as X is in the group I'm getting ready to say, right? And I will say, the double stem R means all real numbers. That's the real number group. So this, let me close it off. We say X, as long as X belongs to the real numbers, or as long as X is real. Literally pronounced the same way that is. But mathematicians like shortcuts, and that becomes less to write. And since you end up writing X is real so many times, or Y is real so many times, we'll just start doing that a lot because it's short. It's technically, you can do it faster than you can do this thing. Same thing here for the range, Y such that Y is real. Double stemmed R. Or if you forget the symbols, or you're not comfortable with the symbols, Y such that Y is real. In Algebra 2 class, and even pre-cal, you'll see these a decent amount still. Even like if you go to like look at some little math website to try to get help, you'll see these written down. Sometimes you'll see these. Interval notation is used Eventually, Algebra 2, like an Algebra 2 course that you're ever like normally looking at, they'll be using these for a while, and then all of a sudden they'll start using interval notation. Without introducing it, they'll just switch over and lose a lot of people that weren't prepared for it. And unless your teacher sees it coming, you're not prepared for it. I like showing them both at the very beginning because I like them both. I don't have a favorite. And it's not true. When these are short and convenient, I love them. These have a special place in my heart because a lot of people don't like them. And usually I like the things that other people don't like automatically. I'll be like, oh, you don't like that? I'll start to see what I like, what's good about that. Set Builder has some really good stuff because if you have special groups or if you can figure out a way to describe it like in a shorter way, it's there. Or if it's something that's really difficult to describe, you can go straight into like, just start writing a paper. X, as long as. X is one of my 5 favorite numbers. My 5 favorite numbers happen to be 7, 12, 14, and 9. Those are only 4 numbers. See, tricky. End braces, there's my domain. Right? That would technically be legal. You can start like literally describing all the things you can do there. That'd be ridiculous, don't actually do that, but it's mathematically legal. It's not mathematically legal to say the domain and just leave it like that. This, perfectly fine, Algebra 1, even geometry. I don't know if you guys did domain range in geometry, probably not, right? Oh, science labs. It's like, we don't have skinnies over here. Why are people leaving? Science lab, right? This is not legal in Algebra 2 anymore. If you're gonna say all real numbers, you gotta put it inside braces with the X thing before it, because that says formally, I'm getting ready to talk about domain. Does that make sense? Because we're getting into like serious math, and it's going to be very helpful and important. Because up until this point, the math we've been doing, the graphs and all the things have been on the basic side, and we're gonna get to some really advanced things. And we have to be very careful before we get into the really advanced stuff and make sure we're communicating everything correctly. And saying specifically what we mean and meaning specifically what we say. Luckily, at first, the math itself is gonna be easy. It's gonna be communicating. You're gonna know the right answers. It's gonna be kind of communicate the right answers correctly. And if I have all real numbers, there's your 3 ways of writing it for domain and range. Switch cameras back. All right, real numbers are gonna be the most common group that we use. There'll be some times that we do the others, but not often at all. In pre-cal and beyond, you'll use the other groups a good bit, especially when you get to the trigonometric functions. Hey, look, this one, yeah, this one covered over right, I think. Yep. So this is the exact same functions written in Set Builder. All real numbers, boom, boom. See, this is kind of nice and short. And if it comes up off a lot, you'll be used to doing the double. That's how you type the double thing. It's like Greek-like letters or symbols in Microsoft Word. If you're writing it by hand, usually just double stem the R. Since Word can get fancy, they double stem the entire letter. Here, this one, the domains all real numbers. That's how, notice I just went straight to inequality. That's fairly familiar, which is one of the things that's nice about Set Builder, is you just have the variable slash, and then you do what you used to write all the time. Correct? Like that used to be the answer. Hey, y is somewhere between here on the inequality. You go to what's familiar after you do your slash. Same thing here, look, inequalities. And that's, if you have, remember this guy was ugly for interval notation? You had the piece, and then you had another piece. It's Set Builder, it's nice. It's like, oh, just don't hit 0. So you can either say, this is what you can do, or you can just slash what you can't do. Does that make sense? That's probably my thing I like the most of that set builder, because usually when I'm trying to figure out a difficult domain or range, I'll usually start with, oh, what's gonna cause me problems? And I'll make a list of all my problem spots, and I'll just say, don't let X be any of these things, or don't let Y be any of these things inside set builder. And I say, don't let them be them by writing that it is them and then slashing them. Going back to the, I'll do it on the floor. Why would I do this on the floor? Not fun.
That's why it's on the floor.
That is why it's on the floor. Someone give me a number. You said 5? All right, X can't be 5. I write down X is that, that's what caused problems, slash it. That now means X can't be 5. Some of you guys have trouble with the inequalities, like switching back and forth. Maybe. Like, let's say X being bigger than 3 causes problems. I could write, and for like domain, like don't let X, that means X can't be bigger than 3. I could write X equals less than or equal to 3, and I can switch it around, which is perfectly fine. Or if for some reason I'm like not a careful math student, I can slash it. That means X cannot be bigger than 3. Almost anything that I do, if I slash it this way, that means cannot do whatever that thing is. That makes sense? Really handy. It's a shortcut for a lot of things. Some other math teachers get bothered when I do it, but it's perfectly legal. They never have a good argument afterwards. They're like, why did you do that? And I was like, because I can. And they're like, oh, well, yeah, but why? No, because I can. So it's handy. If you're ever like getting just a mental block and you can't go on, because yeah, that right there, this X is not bigger than 3, same thing as X is less than or equal to 3. But if I couldn't think about, oh, when I have it or equal to, I lose it, or if I don't have it, I gain it. You can always just slash it. Slashing is kind of powerful. Or if I was really stuck, I'd be like, oh, X can't be bigger than 3. It's perfectly legal to start writing. I know y'all hate writing, but if I can't think about the math, how to mathematically say what I want, set builder's nice, because then I can just start describing what I want. Please don't give me an essay inside a set of braces. Try to figure out how to say what you want within a sentence. I love short sentences, but at least within a sentence would be awesome. If you have to go 2 or 3 sentences, that's okay. Because sometimes you'll just like be stuck there. I'd rather you be right than be like convenient. Okay-ish. Let's see more. All right, that was the end of that. All right, this is for domain or range. Oh, this is more important for domain. Because domain is usually a good starting point. Because if I ever say, hey, what can X be? What math can you do? What numbers can you put in? A lot of students get stumped at different times. And it's not throbbing as bad as I want. It's just not as big as I was hoping it was going to be. I almost need that camera to be up here. It's gonna be hard to get up there. All right. I'm hoping that it's bigger on y'all's screen than it is on mine. Some of y'all might need to get like a 50-inch TV just for your classroom monitor. because I write so small, or because my camera's so small, far away. I'm talking to the virtual people. Don't actually do that, that would be ridiculous. But it's in the back of my head. All right, so huge note, if I'm ever trying to find the domain and I'm stuck, there's two things you typically will look for. There technically could be others, but these are the big two, all right? You always look for what I can't, you don't ever sit there and start, don't think, what numbers can I do that math for? That's what the domain technically is. It's what numbers you can use, all right? There's a whole lot of numbers in the world. And typically, if I can be 2, I can be 2.5. And if I can be 2.5, I can be 2.5000001, right? So I don't want to work through a list of things I can do. It's usually easier to spot things that I can't do. That makes sense? Right? There's two things that will typically cause problems in this class that you cannot do. First one should somewhat be familiar. You cannot divide by 0. All right? Y'all are okay with that, right? You cannot divide by 0. So what I will do is if I have a big ugly function and x is in the bottom of a fraction somewhere, I'll look and say, oh, what value of x would make that bottom part become 0? So, for instance, I'm gonna get faster at the switching back and forth. And I'm doing a lot of switching back and forth so that I get better at it, because that's how you get better at things. You practice them a lot. So, red, yellow. If I had, someone give me a number, any number at all.
-4.
You say -4? If I had this in yellow, y equals -4 over x plus 2. If I'm trying to find the domain for that, I'll look and say, oh, well, I have a fraction with x in the bottom. What value of x would make that bottom part of the fraction equal to 0? Now, what value of x would do that? -2. So I'm like, oh, look, x equals -2. That causes a problem, right? Don't let that happen. So it gets slashed. And I'm gonna build my domain around it. There's my domain. Any x, as long as x does not equal -2. Because -2 would give me a 0 in the bottom, and I can't have 0 in the bottom of the fraction. That kind of makes sense? And that's literally half of the things I look for. That my default is all real numbers, unless I see a fraction where the variable in the bottom, then I go check that out. Or even roots. The other big thing is, and there are technically some exceptions to this. You know, if you become a pure mathematics major in college, you may eventually end up using Riemann's. I can't remember what he called it now. It's different, but either way, you may be doing like multi-dimensional graphing, not just 2 or 3 dimensions, but like 5 and 6. And then you can deal with some of these things, and then your domain won't be as limited, and your range won't be as limited. But then remembering this class will be like a distant memory mathematically. For this class, we cannot take an even root of a negative. Now in this class, the even roots we're going to see that we're going to be graphing, are going to be a square root. You don't know what square root. There are 4th roots, 6th roots, 8th roots, and all that good stuff. There's roots all the way up to as high as you want to get. All of the even ones have the same restriction. We're going to be at 2 because that's a big number for us. So you cannot take the square root of a negative. So if I see a square root symbol in the graph at all, in the function, if I see a square root symbol, I'm gonna look and see if I see an x inside it somewhere. If I do, I think, great. Don't let the stuff in that square root become a negative number. All right? Do you want to see an example of that, or y'all getting it? Not talking to me. And you guys aren't talking to me either. So you can't get mad at them and they can't get mad at you. I'm hoping that we're okay-ish. We're gonna see some things here. So if I'm saying this is my relation rule, it's double the number and then subtract 3 from the result. Find the domain and range. By the way, there's not a big tricks on the range, you just kind of see what you have, and a lot of times you'll graph it first and see what you have. You don't think you can kind of ledger copy. Some people are depending on someone else to ask questions. They are the someone else that needs to ask questions. So if I'm going to double a number and then subtract 3 from the result, are there any numbers that would cause us trouble calculating that? Are there any numbers we couldn't double or subtract 3 from? There's 2 things to look out for. Me being in the bottom of the fraction, is that number going to be in the bottom of the fraction at any point in time? Do I have any fractions? I'm just doubling it. So if I have a number, right, this is the relation. I take a number, I double it, that's times 2, and then subtract 3 from it. That's my thing. 2 times x minus 3. But is there any chance of my x, the whole x being in the bottom of a fraction? You can say no. What? How? You were just being contrary. I'm on the wrong side. All right. So, no, there's no fractions there. So I don't have any issues with that. Or do I have any square root symbols? No. So I'm not going to have any issues. That's typically what's going to happen. Be prepared for there to be no issues. The only big issues you're going to see in this class are my x being in the bottom of a fraction and a square root symbol. If I don't have those 2 things, think no issues. Now the range is a little bit different because I have to actually think about it. Domain is the big deal. The domain is usually asked for, required. It's a bigger deal that you get domain right more than range. For right now. Later on in the class, it'll be a big deal the other way too. So my domain, do you guys like set builder more or interval notation? She said set builder because I like it more. Or I spent more time on it. Okay, I'm going to show them both. Apparently I'm not going to show them both well. So, all real numbers, or the domain goes from negative infinity all the way to positive infinity. Now the range, you either have to graph in your head or picture what can I not get to or what can I get to. Usually with the domain, I'll go from extreme to extreme and see if I'm just kind of doing anything, or I'll picture things in my head. That's going to be easier as we do family of functions and transformations. So know that the range is going to get easier because you're going to be able to picture and graph in your head a whole lot faster. But this guy right here, if it's 2x minus 3, doubling the x minus 3, what does that look like? Generically, what type of function is it? Starts with an L and ends with an I. It's a line. And 2x, the slope is pretty big. It goes like this, right? There's a reason also why I have to come to graphs. We'll talk about that. So it's that. It's a line that goes like this. So how low does it go? Negative what? Negative infinity, right? It goes on down forever. How high does it go?
4.
Yes, which we like to call positive infinity. So that Again, I can't do my braces on this board right the first time. Again, unless something wonky's happening, it's gonna be all real numbers. Be prepared for that to happen. Yeah, it's a fun word. I think it came up a couple of times this past weekend, so now it's stuck in my head.
What, wonky?
Wonky.
One of my friends, so there was this like internet trend thing where this guy was making something and he called it wonky slosh, but then our redneck friend kept saying wonky slosh. It's funny.
Redneck friends, you take anything that's mildly humorous and make it hilarious in like 2 or 3 seconds.
They're like a redneck firm.
I mean, he's not necessarily redneck.
You need to have at least
he's
a couple
southern.
redneck friends at all times.
I don't need to say redneck, I'll just say southern.
Right, so
Because redneck is not the same as southern.
Yeah.
redneck is like hardcore.
Yeah, I was about to say, it is.
Well, I was gonna say, I know
I mean,
some,
I have both
I know some serious rednecks that live way up north.
up north.
Yes.
Yeah, no, I got it.
Really?
The southeast.
Sometimes they're worse because then they're like out to prove something that they can be just as redneck as the people in the south. It doesn't matter where they are. They put some effort into it. The other, like, our rednecks just come by it naturally. Yeah. My brother. We'll talk about. Look at this one. This one has something wonky happening. I was gonna say my brother. He moved to Georgia. My brother, not my brother, my brother-in-law, who was from New Jersey, moved to Georgia because that was as close as he could find. But he absolutely was going to move to the South. He was like absolutely amazed and kept asking me all types of questions. When this was like years back when Coach Marlowe had the fishing club going, he was amazed that we had a sporting clays team and a fishing club at our school. Next thing I knew, he was starting looking for jobs down in the South. He's seriously redneck. Like,
Wow.
I could see him driving a duct tape vehicle.
Don't you need a beater?
Yeah, but like I would not be surprised to find out that like he had like a rusted out part of his pickup truck and he was like, oh, we'll just cover the whole vehicle in duct tape, then we won't have to paint it anymore. Because in his mind, that would make total sense. It'd be like a protective covering.
They don't even use duct tape anymore. They should just let it hang if it's there, or just rip it off entirely.
God bless you.
God doesn't bless.
So the square root of a number, you need to see it mathematically. That's gonna look like this, right? Whatever the number is, I take the square root of it, and that's how I get my result.
No, I think this is what I did for domain rank, but that's just.
That's just going from the words to a symbol.
Yeah, that's a good one.
So what is the so remember, we have two things to look for. Do I have any fractions?
What?
Do I have any fractions? There's two things I look for. I look for fractions where I have trouble in the bottom, in the denominator.
Yeah. Okay.
Do I have any fractions? No. Or I have to be careful of square roots of negatives. Do I have any square roots?
No.
You have a square root, no, negative.
All I have is a square root.
Oh, wait, the.
Did you say
And then I thought.
Hold on, he's going to try to justify it.
No, I'm not even going to.
He's going to start off with, I'm not a freshman.
No, I don't want to talk about it.
Okay, it's embarrassing, it's all
He
right.
was asleep.
So what number, I cannot take the square root of a negative, right? So x cannot be negative, right? That's all I have to do. So I'm gonna write the domain. I'm gonna start with set builder, because that's what I showed it last time. How can I write x can't be negative?
If X is real.
No, because negatives are real.
No.
X cannot equal a negative.
Okay, yes,
So
I
simple.
can literally write x is not negative, period. Great, all right? Because you can use words. Anytime symbols fail you, you can use words.
Yeah,
Just
All right.
right full.
Inside set builder. So like I still have to do the whole brace thing, X line, and then I can start writing words. All right. It's better if you like, get used to it not doing it, because it's awesome if you can find symbols, because math is about finding shortcuts and small ways of writing things. I'm gonna write one up here. But you can, it's totally legal to just start writing words. That's way better than just getting stuck and like not having anything. I have seen problems in math textbooks where they start with the domain and then the domain is so ugly that there's not a good symbolic way of doing it. So they literally write out a description and then close off the brace.
Does it work?
Yeah,
Great. Okay.
all right. It was perfectly legal. It was for a discrete math class where like we actually had like some really complex, ugly groups. And the qualifications to keep you part of the domain was kind of interesting.
Just that it's ugly.
Domains like any x such that x is a natural number that contains the letter E in its name. So like 3 would work, but 4 wouldn't. So like really interesting domains where you're like, really, this is I just kicked out 50, but 51 is okay. So this is x can't be negative, which means x has to be at least what? There's a number that's not positive, but not negative, and he's the border between, okay, 0. So as long as x is greater than or equal to 0, yeah, inequality. A lot of times with these, inequalities are going to be your friend, which is a big reason why we did inequalities last chapter before we got to these, even though we didn't do a lot with inequalities. We did like half a day. I made sure I mentioned them in some way because of set builder notation. Now, also, I can do interval notation because it starts at an interval nicely, right? The smallest number that's going to not be negative is 0. Right? And then once I'm in the positive world, I can keep on going forever. I can actually use 0 because the square root of 0 is 0, but I'll never actually get to positive infinity. That's the domain. It's gonna be a struggle to get to different types of functions. It'll be okay because we're ahead of the common pace. All right, now the range. Range can be kind of tricky, and you can think, right? You can always go to Desmos, graph it, and see how high and low it gets, how far and wide, if it's something that you can graph in Desmos. If you can't, usually you'll end up being able to see it anyways. But soon, this graph, if I am the origin here, this graph is pretty much just a big, I don't know if I can get my arm to bend the right way. It kind of goes up like that the whole time. It starts at 0 and it starts going up faster, then just slowly, it slows out and slowly gets bigger and bigger. Right? Because 0, the square root of 0 is 0. When x is 1, my square root of 1 is 1. I'm just counting how long it takes to get to the next perfect square, right? So I've gone over a step and had to go up a step. I have to go all the way over to 4 before I get to 2, right? Because the square root of 4 is 2. Then I have to go all the way over to 9 before I get to 3. And I have to go farther and farther to go up one more as I go. So it curves slowly, but it does keep on going up, right? So I have any number, but I'm never going to get a negative. I'm not going to get the square root of 16 is not going to be negative something. So y as long as it's 0. So my range is technically the same numbers as the domain, it just takes me a lot longer to get there. That's okay, it happens. Still gonna hit 0 in there. And we will, at least at first, be graphing a lot of these, at least mentally, or I'll give you the graph before we decide on what the domain range is. Okay-ish? See how far we can get. Go to the next page. 1, 2. All right, you guys do this one. No, that's the exact same one. How did I copy in the exact same thing? I didn't mean to do that. All right, here's the difference between relation and function. They're both a set of math rules. People have heard it's called like a mapping from one to the other. It's kind of interesting how it goes. The big deal is anything that takes a number and gives you another number as a result doesn't have to be a different number, but it takes a number, it does math or doesn't do math. The identity function causes lots of problems. There's a function that says, all right, you give me a number, I'll give it right back to you. So even though you realize that's legal, it's a set of math operations. Even if those math operations don't end up doing anything, where I take a number, I do math, and I spit something out. That's a relation. All right, I could spit out numerous things. It's still a relation. Relation is just a set of math rules. A function is a relation where every element in the domain, now technically something in the relation can have something in the domain that doesn't do anything, like they can't work. We're not going to ever have that. We're going to take care of that. But a function has everything in the domain, goes to one place. Right? Does that make sense? So, which kind of makes sense. It's functional if you give me a number and I give you a single result, and I know exactly what to do with that number. Right? A good example would be, a relation would be if you give me a number, I will give you its square and the negative of its square. That would be a relation, right? So if you say 1, I'll say 1 and negative 1. And if you say 2, I'll say 4 and negative 4. That's a relation, right? A function would be if I give you a single answer. So you know what the result is for every single number. Does that make sense? And I use everything in the domain. Quick note, if it's a function and you have something in the domain that you did not use, that usually means that you wrote the domain wrong. Because if there was a 3 here and I didn't need to use it, when I write the domain, I would just cut 3 out. And now it's a function. As long as everybody in there goes one place. Lots of things can go to the same place, but they have to go to one place. Okay-ish? I was asking questions. All right. I don't like this background. It wasn't supposed to be as fuzzy as that. And by the way, on the homework sheet, like the first page is a little bit fuzzy. If you mess up because of the fuzziness and you get like numbers wrong, that's okay. I'm mainly looking for the process more than the specific answers. I didn't realize how fuzzy it was until this morning, and then it was too late for me trying to fix it. So this guy right here, every number has to have one place that it goes. So this one's okay, because 3 goes to 4. Go with me? This number's okay, because 2 goes to 1. 1 goes to 2, that's fine. But this right here causes a problem, because 0 is trying to go to 2 different places at once. Does that make sense? So this guy right here is a relation. This one's going to have issues also. 1 goes to 0, that's okay. 2 is trying to go to 2 different places. Can't do that. It's also a relation. Well, if you guys were expecting me to make one of them a function. All right, function, everything in the domain goes to one place. That makes it functional. Yay, nay? Okay. It's gonna get trickier. We're gonna have more classifications. Whoosh. You guys do this one. I think it stops at 6. Yep, good. And you can use R for relation, F for function, if your handwriting is neat, but it's big and, you know, you don't want to write the entire word. Alex, you do marvelous work.
Thank you. I thought so.
All right, most of y'all got this, and I say most of y'all, nobody got it wrong. Some people said, I'm too good to do his math work in class. Okay, well,
I never said
they'll
that.
teach you. I wasn't even talking about you, Alex. You at least wrote something down.
Oh, I did?
You wrote a lot. I wasn't trying to out you in any way like that. Everything that they heard me say about your stuff was positive-ish. All right, so here, that one doesn't know where to go because he has 2 places to go. My thought on this, and I don't know, like, I know this happened to me when I was a teenager also, but this happens more as an adult. Have you ever been there and have someone tell you to do 2 different things and they both have to happen immediately and there's no way you can do both of them?
Like you be in the middle of doing one thing and you have to go do another thing.
Yes, my wife is awesome at that. She's like, I need you to do this, which involves me going to the store, and I need you to do this, which involves me doing stuff at the house. And she's like, and I need you to do them both now. And I'll end up just standing there not doing either of them. No, but you gotta pick one. Because I'm a function person, right? I cannot function in 2 different places at once, and I can't split up. So this guy right here, just a relation. Because I can actually write out the whole word because there'll be some people confused if I remember to share this like I'm on to. Right? That one causes issues. Here, 1 goes to 2, 2 goes to 4. I don't have the same X in here going to 2 different places, do I? No. So we're good. That makes it a function. Everybody knows what to do. 1 goes to 2, 2 goes to 4, 3 goes to 6, 4 goes to 8, 5 goes to 10, 6 goes to 12. Right? If you know what you need to do, you can function. Just trying to make things click in your head. Things that will help you remember things later on. We are going to just barely get onto this. We're not going to get into this in depth because of time. We can do this a little bit. If I am a function, there's 3 types of functions. This guy right here is probably the most common. I'm actually not writing. I meant to be able to write on this. Oh well. Onto is the basic one. And I like to think of like school dances as my example for the different types of functions. You guys have been to, see, school dances used to be so much more of a thing when I was, when we were in the 20th century as opposed to the 21st. And I've done my best to avoid school dances for some time, like ever since I got older than the people in them. Being an adult at a school dance, not so much fun. All right, so first thing is, in order to be a function, right? I like to think of the domain as the guys, they're the dudes, and the range are the ladies. Realize this is gonna take me a whole lot from going with my 20th century analogy, and things are so different now, but you can, picture an old movie, think of a school dance in some way, at some point, think about this. So, function means every single guy there is going to one lady to dance, right? Or one partner, right? That makes it a function.
You don't even sound right.
No, keep going. I don't know where he's on.
Oh, I don't know, I'm thinking about something.
It's a function if every guy there is going there with a lady or a person. I don't care what the person is.
No, it's not.
All right. It's a dance.
Yeah.
Not talking about anything after the dance.
Yeah.
Okay. That makes it a function. Everyone that's there has a part. It's an onto function if everybody in the range has somebody from the domain there. Does that make sense?
One person just might have to.
Good. There can be, so like, I can think I'm going to the dance with Mary, and he can think he's going to the dance with Mary.
There might be twins, you never know.
That's okay, as long as every guy has their eye on one girl. That makes sense? That makes sense?
Yeah.
We're gonna ride this analogy and hope that like I don't get in trouble in any way, because it makes the math work. All right? It's a function if every guy has their eye on one girl.
It's okay, 3 or 4 are twins.
It's an onto function if every girl is being eyed by some guy. Right? Onto means that the entire range gets filled up. Almost always it's gonna be at least onto. All right? That means you're gonna fill up your range, because if there's a part of your range that doesn't get filled, you usually cut it out of the range, right? If that girl is there and nobody likes her, she's gonna go home. We're gonna kick her out of the range being like the dance hall or something. All right? That makes it onto. It is a 1-to-1 if every guy has their eye on one girl, and every girl is being eyed by only one guy. So, another thing about it as far as the dance goes, it's a function there. If all the guys go to the dance, it's an onto if there's nobody sitting being a wallflower. If everybody is dancing, right? Onto means everyone from the domain is dancing with somebody, and everybody from the range is dancing with somebody. These two guys can be dancing with that one girl. That makes sense? As long as everybody's on the dance floor, it is onto. That makes sense? There's nobody standing off by themselves watching everyone else dance. That is onto. It is 1-to-1 if it's like couples dance and everybody's on the floor. That makes sense? Everybody has a unique pair. One goes to, in this case, D, and D only is dancing with one. That make sense? And this is how I think about it. It's a function if all the guys are dancing. It's onto if everybody is involved in the dance. There's nobody being left out. Onto means no one gets left out. 1-to-1 means that everybody's there with the couple. Now, technically, it's going to be both. If it's this and not that, you're going to change the range. You're only going to have this situation where it's just 1-to-1 if you are given, this is the domain, this is the range, and they left things out. All right? Because this is technically 1-to-1 because it's all just partners. Not onto. That's a very special case. You want to keep track of that. It's only going to be a special case. It's going to pop up like today and like in tonight's homework, but after that, never again. It's going to either be on to or it's going to be both. Both means everybody's on the dance floor and it's a couples dance. Oh, I can't like type. So ready, 1-to-1. That makes sense. 1-to-one's only couples. If you're on the dance floor, you know who your partner is. So I'm gonna run out of time and we're not gonna be able to like run into examples of this. We'll do examples of this tomorrow. On to is everybody's on the dance floor. And both means everybody's on the dance floor and everybody is in the couples dance. That kind of makes sense. Does the analogy just hold a little bit? We're gonna practice this and get better at the words because we're gonna run out of time. But those are the big three. And we're gonna see how they like end up looking graphically. And are people really leaving or is that sign? I think that's the science of that. You virtual people can go ahead and head out because like I put a homework sheet in the Google Classroom under classwork. It's not bad. I think there's like 12 or 13 questions, but a lot of them are just, what's the domain range? What type of function is it? You technically can do it all now. Don't freak out. On the first side, it says like discrete or continuous. That just means is it all one piece or is it there any breakages? Discrete means there's breakages. Technically, discrete means something more specific than that, but it's because we're technically beyond discrete or continuous, even though our textbook doesn't realize that, because there's more than just those two different categories. Because you can have continuous sections that aren't technically discrete, and most of our interesting functions are not going to be continuous or discrete. They're going to be continuous with different sections. How is it not? Oh, forgetting that my clock is a few minutes fast. All right, stop the recording. Because there's nothing else interesting happening.